Here are the answers for the Chapter 13 review worksheet. Number 1, write the first four terms of an arithmetic progression given these values. The letter A represents the first term. Sometimes that's even called A sub 1 to clarify that that means the first term. So if you ever see A sub 1 in a textbook, it means the first term of a sequence. So the first term is given to us, it's 6. We need to find 3 more. And to do that, we're going to use the value of D, the common difference. For an arithmetic progression, you add the value of D to get the next term. So 6 add 3 is 9, 9 add 3 is 12, and 12 add 3 is 15. Here are the first 4 terms. Number 2, find the 21st term of an arithmetic progression. Because the 21st term is so far along in the sequence, it's not going to be efficient to actually list out all of the numbers like we did in problem 1. So instead, let's make use of the general term formula. It is T sub n, or maybe A sub n, that doesn't matter, equals A plus n minus 1 times D. So for T sub n, what we're interested in is T sub 21. These symbols mean the 21st term. The letter A is 5, the letter N is 21, and the letter D is 15. Then take a calculator to evaluate that. And the answer is 305. Number 3, what is the arithmetic mean of 2 and 18? What that's asking for is if 2 and 18 are the first and last numbers of an arithmetic sequence, what is that middle number? It's going to be midway between 2 and 18. One way to find it is with the general term formula that we just used, but another way to find it is by adding the two numbers together and dividing by 2. So this makes 20 divided by 2, which is 10. Now the next one, insert 7 arithmetic means between -8 and 80. So we have -8 and then 7 unknown numbers. Then 80. This time I am going to use the general term formula to get the answer. The -8 is the value of A, or A sub 1, and 80 is the 1, 2, 3, 4, 5, 6, 7, 8, 9th term in the list. It's A sub 9. Remember, our general term formula is T sub n equals A plus n minus 1 times D. For T sub n, let's use the value of 80, which is the 9th term. A is -8. Again, if the 80 that we used is the 9th term, then n is 9. The variable D is the one we don't know. By solving this equation, we can figure out the common difference. First, add 8 to both sides. This makes 88 equals 8D. Therefore, 11 is equal to D. Now start adding 11 from term to term. -8 add 11 is 3. 3 add 11 is 14. Then 25, 36, 47, 58, and 69. 69 add 11 is 80. Number 5, expand the series and evaluate it. Start with this value for n. So we're going to input a 1. 2 times 1 is 2. 2 subtract 3 is -1. Now work your way up for values of n until you reach the upper boundary at 8. So now we're going to fill in a 2. 2 times 2 is 4, minus 3 makes 1. Now fill in a 3. 2 times 3 is 6, minus 3 is 3. Now fill in a 4. 2 times 4 is 8, minus 3 is 5. Now fill in a 5. 2 times 5 is 10, minus 3 is 7. Now fill in a 6. 2 times 6 is 12, minus 3 is 9. Now fill in 7. 2 times 7 is 14, minus 3 is 11. And now fill in 8. 2 times 8 is 16, minus 3 is 13. We were supposed to fill in all numbers for n from 1 through 8. That would be 8 numbers. So let's check to make sure we got 8 numbers in our expansion. 1, 2, 3, 4, 5, 6, 7, 8. Yep, I don't think we missed any. And looking from term to term, I see a consistent pattern of adding 2 every time. So that's another good thing to check for, that you haven't made a silly math mistake. Now we're supposed to evaluate this. So because we've listed all the numbers out, let's just type them in a calculator and hit enter. -1 plus 1 is 0. 3 plus 5 is 8. Plus 7 is 15. Plus 9 is 24. Plus 11 is 35. Plus 13 is 48. We can check that answer 48 using Gauss's technique. -1 plus 13 makes 12. 1 plus 11 makes 12. 3 plus 9 makes 12. And 5 plus 7 makes 12. We can create 4 pairs, each equaling 12. 4 times 12 is 48. Number 6, find the sum of the arithmetic progression given these values. Let's use the sum formula. S sub n equals n divided by 2 times 2a plus n minus 1 times d. And we want to find the sum of 14 terms. So it's 14 over 2, and then in the brackets, 2 times 16 plus then 14 take away 1, and d is 0.5. Now take a calculator to evaluate this. Inside the brackets, 2 times 16 is 32. 32 plus 13 times 0.5 makes 38.5. Then multiply that by 7. So the final answer is 269.5. Next, number 7. State whether the sequence is arithmetic, geometric, or neither. For arithmetic, there needs to be a value of d. There has to be a number that you add or subtract each time. For geometric, there needs to be a value of r. There has to be a number that is multiplied each time. If it's neither of those, then we're going to say neither. So what's happening from term to term? This one here is adding 8, but from 10 to 50 it does not add 8. So arithmetic is out. Now let's check geometric. This is timesing by 5. And then 10 times 5 is 50. And 50 times 5 is 250. Geometric is out. So the answer is neither, because there's no common difference or common ratio. Notice you have to be careful to look at all the terms, because if you only look at the first couple terms, it does look like you're timesing by 5. It's only in this spot right here that 50 times 5 is not 220. You don't want to get tricked. Next, number 8, write the first 4 terms of the geometric progression. So the first number is 3, and then we're told what to multiply by to get the next number. So 3 times 4 is 12. 12 times 4 is 48, and 48 times 4 is 192. Number 9, find the first term of the geometric sequence when the 7th term is 4 and the value of r is 0.75. Let's use the general term formula. So t sub n equals a times r to the n minus 1. For t sub n, let's use the 7th term, which is 4. A we don't know, r is 0.75, and when we chose 4, it was because we were using the 7th term, so n is 7. Now let's solve this equation for a. So we have 4 is equal to a times 0.75 raised to the 6th power. If we divide both sides by 0.75 to the 6th power, that will get the letter A alone. And the result is 22.47 if you do some rounding. Number 10, find the geometric mean between 12 and 18. So if there was a geometric sequence with 3 numbers and 12 was the first and 18 was the last, we're looking for the number here. But don't confuse this with arithmetic mean. We're not looking for the straight average where you add these together and divide by 2. Instead, to get the geometric mean, the formula is to do the square root of the first number times the last number. If you don't want to solve the problem like this, you can use the general term formula for a geometric like we did in number 9. So this makes the square root of 216, and that's equal to 14.69 if you round it. Now number 11, expand the series and then evaluate it. So first, fill in 1 for n. 1 minus 1 makes 0. 2 to the 0 makes 1, and negative 3 times 1 is negative 3. Now fill in 2. 2 minus 1 makes 1. 2 to the 1 makes 2, and negative 3 times 2 is negative 6. Now fill in 3. 3 minus 1 makes 2. 2 to the 2 is 4, and negative 3 times 4 is negative 12. Now fill in 4. 4 minus 1 makes 3. 2 raised to the 3 makes 8, and negative 3 times 8 is negative 24. Now fill in 5. 5 minus 1 makes 4. 2 to the 4th power is 16. Negative 3 times 16 is negative 48. Now fill in 6. 6 minus 1 makes 5. 2 to the 5th power is 32. And negative 3 times 32 makes negative 96. Now fill in 7. 7 minus 1 makes 6. 2 to the 6th power makes 64. And negative 3 times 64 makes negative 192. Starting at n equals 1 and going to n equals 7 means there should be 7 terms. Let's check that. 1, 2, 3, 4, 5, 6, and 7. That checks out. Because this number is negative 3, that means the first term should be negative 3. That checks out in our answer as well. And because the multiplier is a 2, we should be timesing by 2 each time. So as you look from term to term, are they doubling? And that seems to check out as well. That's expanding it. Now we have to evaluate. So since we already wrote out all the numbers, let's just type them in the calculator to get the answer. And the result is negative 381. The other way you can evaluate the answer, if you don't want to add up so many numbers, is to use the formula for summing a geometric. In that formula, you need to know A, R, and N, and we do know all those numbers. We know A is negative 3, R is 2, and N is 7. Next, number 12. Let's use a formula to find the sum. There are 2 sum formulas in the notes, and you choose which one to use depending on what information you have. In this problem, we're given A, the first term, and L, the last term. So I'm going to use the sum formula that involves those. It is S sub n equals A minus R times L divided by 1 minus R. So in this problem, our sum is going to be 5 minus 4 times 200 divided by 1 minus 4. Now type that in a calculator to get the answer. Make sure you're typing the numerator in first and pressing enter before you divide by the denominator. This will make negative 795 over negative 3, which is equal to 265. Next, number 13. What must be true of the value of R so that an infinite geometric series has a sum? The absolute value of R has to be less than 1. Now, number 14. Find the sum of the infinite geometric series below. Well, what's the value of R? From term to term, R is equal to 2. The numbers are just going to keep getting larger and larger and larger. you won't be able to find that sum. So this is undefined. Now, if this infinite geometric series had a value of r that was less than 1, then you would be able to find the answer using a formula, and this would be the formula. But in this particular problem, because r is equal to 2, the answer is undefined. Number 15, here's the 8th row of Pascal's triangle. Underneath, write out the 9th row. To build the rows of Pascal's triangle, you use the numbers from the previous row. Start the row with a 1, but then to get the next number, you add these together, 1 plus 7, and that makes 8. Then 7 plus 21, that's 28. Then 21 plus 35, that's 56. Then 35 plus 35, that's 70. 35 plus 21 is 56. 21 plus 7 is 28. 7 plus 1 is 8. And then you end the row with a 1. Notice how I'm writing down the sums kind of in between the numbers above which generated the sum. The 9th row should have 9 numbers in it. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it will always begin and end with a 1. Now, number 16, expand the binomial. It goes to the 5th power, so we need to choose the correct numbers from Pascal's triangle. From our note page, those numbers are 1, 5, 10, 10, 5, and 1. This has 6 numbers in it, and it's from the 6th row of Pascal's triangle. So when the exponent on the binomial is a 5, you're actually using the 6th row of the triangle, because the 1st row of the triangle corresponds to when this exponent would have been a 0. Now let's use those coefficients along with this term and this term to create the expansion. It's 1 times b to the 5th, c to the 0, plus now 5 times b to the 4th, c to the 1, plus now 10 times b to the 3rd, c to the 2, plus now 10 b to the 2, c to the 3, plus 5 b to the 1, c to the 4, plus 1 b to the 0, c to the 5. I've used all those coefficients from Pascal's triangle, but notice how I've manipulated the exponents on the b and the c. The sum of the exponents is always 5. 5 plus 0 is 5. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 1 plus 4 is 5. 0 plus 5 is 5. As you move across in the terms, you're decreasing the exponent on the b, but you're increasing the exponent on the c. Now run through this again and give it in simplest form. So this is b to the 5th power, then 5b to the 4th c, then 10b cubed c squared, 10b squared c cubed, 5bc to the 4th, and then c to the 5th. Number 17 is another expansion of a binomial. So we need to pay attention to the first term, the second term. This one has a minus in the middle. That's going to affect the signs of the terms in our answer. And this one goes to the 6th power, so we need the 7th row from Pascal's triangle. Let's look up the 7th row of the triangle first to get our coefficients. It's 1, 6, 15, 20, 15, 6, 1. 1, 2, 3, 4, 5, 6, 7 numbers. Now it's kind of a strange concept to want to look in the 7th row when the exponent on the binomial is a 6. So a lot of times Pascal's triangle will say that it starts with the 0th row. And by calling that first row the 0th row, that makes the rows of the triangle match the exponent on the binomial. Now let's do our expansion. It's 1 times 3a raised to the 6th power times 4b to the 0 power. Now a minus sign. Then it's 6. Now 3a to the 5th power and 4b to the 1st power. Now a plus sign and 15. Then 3a to the 4th power, 4b to the 2nd power. Now a minus sign and 20. 3a to the 3rd power, 4b to the 3rd power. Now a plus sign, 15. 3a to the 2nd power, 4b to the 4th power. Now a minus sign and 6. 3a to the 1st power, 4b to the 5th power. Now a plus sign and a 1. 3a to the 0 power, 4b to the 6th power. Before you simplify this, you should run through and make sure that you've done all the steps correctly. Do you have your coefficients in there? Does it alternate signs? The first one's positive, then minus, then positive, then minus, then positive, then minus. Have you counted downwards on your exponents while the other one is increasing to correspond, so that they always add together to make a 6? After you've checked all those things to try to avoid silly math mistakes, now simplify it. So this very first term makes 729 a to the 6th power. Now do the next term. We're going to have to go 3 to the 5th times by the 6 times by the 4. That makes 5832 a to the 5th b. Now this next term, we're going to have to go 3 to the 4th times 4 squared times 15. That makes 19440 a to the 4th b squared. Now we'll do this next term. We're going to go 3 to the 3rd times 4 to the 3rd times 20. That's 34560 a to the 3rd b to the 3rd. Okay, now this next term, we're going to go 3 squared times 4 to the 4th times 15. That's 34560 again. A squared b to the 4th. Okay, now this term. This time we're just going to go 3 to the 1st power, just 3, times 4 to the 5th times a 6. That's 18432. A b to the 5th. And now we'll do this last term. The 3a to the 0, that just all makes a 1, so I guess we're going 4 to the 6th power for our coefficient. And that's 4096. B to the 6. Run through it again and make sure your signs do alternate. Positive, negative, and so on. You could even run through and make sure your exponents seem to follow the correct pattern. As far as getting the correct coefficients, you need to make sure that you've typed correctly on your calculator as you were doing the math in each of the different terms.